Geothermal energy is generated and stored in the Earth's crust. It originates from the original formation of the planet, from radioactive decay of minerals, from volcanic activity, and from solar energy absorbed at the surface. Geothermal gradient, which is the difference in temperature between the core of the planet and its surface, drives a continuous conduction of thermal energy in the form of heat from the core to the surface. The sun heats the first few feet of the ground. This heat is lost during the night. During the winter months, this temperature is much greater than the average temperature of the air above the surface. To extract this heat, hundreds of meters of piping are run under the ground. These pipes are then filled with water, and a pump pushes cold water through the pipes to the exit area. The water is collected in a boiler where it can be directly channeled to mechanisms such as underfloor heating, or it can be heated to a higher temperature by the boiler and used for the building's hot water supply. However, drilling 3 miles below the Earth, though possible, is a very difficult task. Instead, there are areas known as geothermal hotspots, which is an area that transmits excess internal heat from the interior of the Earth to the outer crust because of reduced thickness in the Earth's mantle. These areas are identified to derive geothermal energy. These geothermal hotspots could be used to generate electricity. It is also possible to pump hot water into these sedimentary hotspots. The steam generated by this method is used to produce electricity. The condensed steam is again circulated into the permeable sedimentary stream of a hotspot. When using volcanic magma, the temperature of partially molten magma is approximately 650 degrees Celsius. This heat is used to boil water to generate electricity. The magma must be hardened and extremely hot, dry rock. Pipes are looped through these hot, dry rocks, through which water is circulated. The heat of the rocks converts the water into steam prior to transferring the heat to a steam generator. China, which is dependent on coal and oil, could benefit from using more geothermal energy. Geothermal energy is a renewable energy source, while coal and oil are not. This means that geothermal energy can be reused, and once coal and oil have been used, they cannot be used again. In China, this technology would best be used in big cities such as Beijing and Shanghai, which suffer with big pollution problems. Generating electricity with geothermal energy helps to conserve non-renewable fossil fuels, and by decreasing the use of these fuels, we reduce emissions that harm our atmosphere. In this way, geothermal energy could really benefit the world nationally.
Today, geothermal energy can be thought of as an alternative to fossil fuels, possibly reducing global warming. It is used for various things like electricity generation, district heating, industrial processes heating, agricultural applications, greenhouses, and mineral recovery. In colder temperatures, the energy can be collected for air conditioning, and in hotter temperatures, the energy can be collected for heat and electricity. Geothermal energy can be found in areas near tectonic plate boundaries, and so geothermal electric plants are built in those specific areas because of the high temperature geothermal resources. The largest current group of geothermal power plants, called the geysers, are located in Northern California. Other geothermal systems are located in the Imperial Valley in Southern California and the Yellowstone region in Idaho, Montana, and Wyoming. The use of geothermal energy is expanding, and more demonstration projects are located in Germany, France, Australia, the UK, and the US. When geothermal energy is drawn from the ground, carbon dioxide, hydrogen sulfide, methane, and ammonia are also derived that could add to the global warming and the increase of acid rain. Unfortunately, direct geothermal heating systems contain pumps and compressors which could consume energy from a polluting source. Plant construction can affect land stability, resulting in land caving and sinking of an area, which has occurred in New Zealand and Germany. At the geysers, the largest complex of geothermal power plants in the world, power is sold at 3 cents to 35 cents per kilowatt. The kilowatt is a unit of energy equal to 1,000 watt-hours, or 3.6 megajoules. A power plant built today would probably require about $5 per kilowatt. The initial cost for the field and power plant is around $2,500 per installed kilowatt in the US. There are minimal environmental costs with using this energy source. Geothermal fields still produce carbon dioxide, but only about 1/6 of the carbon dioxide that a relatively clean natural gas-fueled power plant produces. As a result, emissions are generally low. Many geothermal power plants require 450 to 600 gallons of water per minute. Since these power plants require so much water, this could cause issues in places where water resources are low. Some geothermal plants produce solid substances, and some of those solids are now being extracted for sale, like zinc, silica, and sulfur. The plus side to using geothermal energy is that salts and dissolved minerals contained in geothermal fluids are usually reinserted with excess water back into the reservoir. This recycles the geothermal water and replenishes the reservoirs.
Although China has not started the program, China's Ministry of Land and Resources stated in its 2005 Chinese Geothermal Environment Bulletin that the geothermic energy utilized in China will be 10,770 megawatts, thus making China the top user of geothermal power. Although the initial costs of geothermal energy production are very expensive, the costs of drilling are improving. The drilling is the most expensive component of geothermal power because the hot rock that is being drilled into is extremely corrosive. Despite the fact that geothermal energy is not 100% environmentally friendly, it is considered one of the most harmless sources of energy available. Geothermal energy is also considered to be emission-free because the steam coming out of the power plant's towers is almost completely water vapor. Geothermal energy is a renewable energy source, unlike the fossil fuels which take millions of years to form. Geothermal energy power plants take up less land than other major energy sources and emits no harmful products such as radioactive waste. Geothermal energy facilities last very long. Every power plant built in the last 100 years is still generating energy. And although initial costs are extremely high, there is no need to buy fuel. There is more geothermal energy than coal, oil, and gas. Geothermal energy sites cannot be located anywhere. There are certain areas where hot molten rock is closer to the surface of the earth. These areas are sometimes in remote areas. The major ones in the US are located in Hawaii and Alaska. Geothermal energy is the most expensive kind of drilling because of the corrosive hot rock.